Okay, square root of a number. Recall that the square of 3 and negative 3 is 9. This is how we know that. 3 squared is the same as 3 times 3, which equals 9, or a negative 3 squared, negative 3 times negative 3 also equals 9. The definition of a square root of a number, well, if b squared equals a, 3 squared, if that's a b, equals a, that would be 9, then b is a square root of a. b, which represents 3 in here, is a square root of 9. So then 3 is a square root of 9, the definition. Another thing to note here is all positive real numbers have 2 square roots, a positive and a negative. The positive square root, and I'm going to abbreviate because I don't want to write square root a bunch of times, so it's just going to be squirt. The positive square root is also called the principal root. 9 equals 3 squared, which is positive 3 for the square root. If it's positive, a negative, notice how I have the negative inside a couple parentheses there, and 9 would also equal negative 3 squared. Again, negative 3 times negative 3, positive 9. Our square root would be negative 3 in this case. So these two guys together, the square root of 9 is positive and negative 3, 3 and negative 3. Remember, there's 2 square roots for every square root number out there. Okay, a couple other things here. We have the radical symbol here. Some of you may know it as the square root sign. The number inside is called the radicand. 9 is the radicand. Let's do an example. How do we read square roots? We're going to have an equation, and we'll have the words. So in A, this simply says, I see a radical symbol there, and I see a radicand, and equals 3. This says the positive, notice out here there's no negative sign. No negative sign. So this is a positive. The positive square root of 9 is 3. That's how I read that. That's how I would say that. In B, we have a negative in front of the square root symbol. And the way we read this is the negative square root of 9 is negative 3. Our last one here, remember what I said, we have 2 roots. Positive, negative, square root of 9 equals positive or negative 3. So the positive and negative square roots of 9 are 3 and negative 3. That's how we read them. Okay, so let's evaluate one. Evaluate the expression. We're going to do 4 here. You can see I got 4 in a row. A, B, C, and D. A. Notice the positive, negative, there's just a positive, so the positive square root of 64. I would rewrite the problem equals, right here, to go from here to here, I'm thinking, okay, I need to think of something. I need to think of something times itself, a number times itself to get 64. Well, that's 8. 8 times 8 is 64. So I'm going to rewrite it, the square root of 8 squared inside. And then I know that also 8 squared, to bring that out of the square root symbol, is just 8. So I know that 8 is the positive square root of 64. In B, we put the negative there. And so the negative square root of 64, as I go through the same process, what times itself equals 64? 8 squared works. And I would have negative 8 as the negative square root of, what's the square root of negative 64? Negative 8. Here I have 1 root. Here I have 1 root. Here we have, what is positive negative square root of 64? Going through the same process, I rewrite the problem on my paper. Positive, negative, what number times itself gets me to 64? Well, 8 squared. And the way I would write this answer is plus or minus 8. 2 square roots. There's our 2 square root possibility. And then I have a special case here. The square root is 0. How do we do that? Well, what number times itself gives you 0? 0. 0 times 0. Well, it has to be by itself, not like 0 times 1. 0 times 0. 0 times 0 is 0. So I would just rewrite it, square root of 0 on my paper. I could put 0 squared. Of course, 0 squared, and that allows me to bring it out from underneath the square root sign. But the answer is 0. And that is just 1 square root. So the answer to what is the square root of 0 is 1 square root called 0. Okay, something else I want you to recall is perfect squares, because perfect squares and square roots, if it happens to be an integer for the square root, comes out really awesome. So we have, here's, if you remember, if I just had 1 square, the side is 1, this side is 1, and I said, hey, what's the square root of 1? Well, you would tell me 1 because this is actually a perfect square right here. All sides are the same in a perfect square. And what number times itself gets me to 1? 1 does. 1 times 1 is 1, so therefore the square root of 1 is 1. We'll take a look at what's the next perfect square that I can think of. Some of you are thinking, oh, 2. Well, no, it's 4. Look at this. 4 squares. 1, 2, 3, 4. 2 on each side, because 2 times 2 is 4, and we know that the square root of 4 is 2. Comes out great. If we can think of perfect squares, we can find the square roots if we have those memorized. What is the square or perfect square of this number here? This is a 9. The square is a 9, perfect square of 9. Square root of 9, of course, is 3 times 3, which would give us that area. And the square root of 9 is 3. We've kind of used that. What kind of numbers does that always give us? When we have a perfect square, underneath the square root sign, what kind of numbers do we always get? We get the rational numbers. If you remember, those are decimals that terminate. For instance, look at that. That number terminates. That's a terminating decimal because, stand by, because 1.1 is the same as 1.0. It terminates. Doesn't go on. We're done. The other kind of number that we get with rational numbers are repeating. And a lot of you may know this one. 2/3 equals, well, that's 0.66 forever and a day. Rational numbers. It's always nice to work with rational numbers with the square root sign because we know we're working with a perfect square. So when we ask for what the square root of something is, when we look inside, we're hoping for a perfect square. Perfect squares give us nice rational numbers to work with, and the decimals are either terminating or they might be repeating. Still easy to work with. What happens when we don't have a perfect square? Over here, as you can see, 2 squares put together, that's a rectangle. So the square root of 2, I got to bust out my calculator and I need to figure that out and round it. So all these numbers here are rounded. Tens, hundreds, thousands. I rounded them all to the thousands place, third place over there on the right-hand side of the decimal. Square root of 2 is approximately 1.414 because 1.414 times 1.414 is 2. Square root of 3, approximately 1.732. And remember, this thing is going to go on. The decimal is going to go on forever. Notice these are not perfect squares. They're just, they're just squares put on there. That's a rectangle. That's not. Neither is that. So five blocks put together, there's no way I can make it look as nice as one of these perfect squares over here. Square root of 5, approximately, I punch it into my calculator and it gives me 2.236. That's rounded to the thousands place again. But if I multiply that number twice, I'm going to come up with 5, or I'm going to be super close to it, unless I want to actually use my calculator. What kind of numbers are these? Well, we said that they're non-terminating, they go on forever, and they never repeat either. These are the irrational numbers. They're irrational because, well, they don't terminate. They're not nice. They're not nice like these guys are to work with. They're not the same thing like these guys, like the repeating. They're irrational. They're decimals that are non-terminating and non-repeating. So it's one kind of decimal. It's one kind of decimal. It goes on forever and it never repeats. Some of you might remember the example pi. Pi is like that, 3.14, and it goes on forever. Over here, I have two kinds of decimals that are distinctive. One's terminating, like this, and one is repeating. So all in all, under the real number system, this is just a recall, we've got 3 kinds of decimals. It can either be terminating, or repeating, or non-terminating, non-repeating. Remember, this is one kind of decimal over here. Okay, our last example for this video. Evaluate the square root of b squared minus 4 times ac when a's 1, b's -2, and c is -3. A case where we're going to evaluate, substitute in, and simplify or solve the problem. Here's how we do it. We start off with the square root symbol, and we insert -2 in for b. Notice I use my parentheses there. Always use your parentheses. -2 squared minus the 4. The 4 comes from there. Now I'm going to plug in a 1 for a with the parenthesis. Plug in the plug in the -3 for c, which is right here. Parenthesis. And now we're just going to start to solve or simplify. -2 squared is the same thing as -2 times -2. And I went ahead and did the left to right order of operation here first for this particular one. 4 times 1 is 4. So -4, and I brought the -3 down. Next step, -2 times -2, we all know is a positive 4. And a -4 times a -3, positive 12. So I just multiply. Here I'm just going to add. I get square root of 16. Thank goodness. This thing was a perfect square for me. Thank goodness. So 16, I start thinking, what numbers times, what integers times themselves? And I know 16 is a perfect square, so that means the sides of that square have to be 4, because 4 times 4 gives me the area, and the area is 16. So square root of 16 would be 4. Think of a factor that could be the square root of 16. You're always trying to think of factors. What can I multiply a factor times itself to get me the answer that's underneath the square root sign.